Alrighty, last Punnett square that we're going to be going over is the dihybrid cross. So if you remember, di means two, di means two, and then that term hybrid refers to combining things or including two separate things. So when we think of a dihybrid cross, I want you guys to think of 2. That's the key number. And what we're going to be creating, if you notice this box is a lot bigger, we have 16 squares instead of 4. We're going to be looking at 2 different traits that are being inherited together in any kind of organism. So let's take a look at our first example. We're coming back to the pea plants from the original Punnett squares that we did, and we're looking at homozygous tall and heterozygous green. So all of that is describing one pea plant. That's parent number 1. Parent number 2 is homozygous short and white. So now let's establish what's dominant, what's recessive. I'm using the same information from that first Punnett square. Remember that we decided that tall is going to equal our dominant trait, dominant, and then a short plant was going to be the recessive. So now, plant height, tall versus short, that's one of the traits. The second trait that we're going to be looking at, green versus white, is going to be color. So if you remember, it's always the heterozygous individual that tells you what your dominant trait is going to be. Because green is associated with the heterozygous and white is associated with the homozygous, we can assume that green is going to be our dominant color, and then white is going to be our recessive color. So for the allele key, remember this is where you pick your letters and you determine what they represent. I'm going to use the letter H again, just like we did in the first one. So that's going to be capital H equals tall, little h equals short. Now let's come to our color. We could use the letter C, but that's probably not a good idea since uppercase C's and lowercase C's, it's pretty hard to tell which one's which. So let's go ahead and use the letter G because it's easy to tell upper from lowercase. Capital G is going to be our green. Little g is going to be our white. So that's your allele key. Now for the cross, this is where we determine what the parents are. Parent number 1, homozygous tall, so I'm using the letter H, so that's big H, and heterozygous green. Heterozygous is different, so that's big G, little g. So notice that in this kind of Punnett square, each parent is actually going to have 4 alleles, not just 2 anymore. And we cross that with parent number 2, who is homozygous short and white. So homozygous short, that's little h. Homozygous white, that's little g. Alrighty, so now comes the tricky part. You need to figure out what letters to put across the top and down the side of your Punnett square. You don't just randomly throw in letters. You have to do a certain formula. I'm actually going to do this on the back so that I can write it bigger. So we're going to look at that first parent. They were capital H, capital G, little g. That was their genotype. So if you are familiar with something called the FOIL method from math, that stands for first, outer, inner, last. So now when you come to your genotype, you want to apply the FOIL method to this. How do you do that? So what I like to do is I like to pretend that there's an imaginary line between these two. I draw in a little dotted line. I'll make it a little bit darker so you guys can see it. And this represents one side of the situation. This is the other side. So when I'm trying to combine things, I want to combine the first letters. This is the first letter on the H side. This is the first letter on the G side. So I'm going to combine these two. So big H, big G is one of my possible combinations. When I want to combine the outer, this H is on the outside, this G is on the outside. So I'm going to combine these two. So that's big H, little g. I want to combine the inner next. This H is on the inside, this G is on the inside. So I'm going to combine these two. So that's big H, big G. I'm going to do the same thing. This is my last H on this side. This is my last G on that side. I'm going to combine those two. So that's going to be big H, little g. So these are my possible combinations. I'm going to put combos for one parent. So now what I'm going to do is I'm going to bring this information back to the front, and this is going to go across the top for that first parent. So that was big H, big G, big H, little g. It was big H, big G again, and big H, little g. So now what you do is you want to be able to do that again for the second parent. For this example, that one is pretty easy because if you draw your little line down the middle of them, you'll notice that you're only going to come up with one kind of combination, and that is little h, little g for all of them. So down the side, you could just write little h, little g 4 times. Alrighty, so now when you combine these together, couple rules you want to follow. Remember, the first one is capital letters come before lowercase letters, but the new rule is that you want these genotypes to follow the same pattern as the parents. So what I mean by that is that the H needs to come before the G. Okay, so if I were to bring these together, I'm going to combine my H's first, so that'll be big H, little h, and then I'm going to combine my G's, that's the second one, so big G, little g. Okay, so once you have this entire box filled in, I'll fill in one more. So that would be big H, little h, and that one would be big G, little g. So again, once you have all of this completed in, you want to do your ratios, geno and pheno. For this kind, for the dihybrid cross, again, I'm going to write a note here for the ratios. There's my note. Only do what's in squares. So if I were to make you do all of the possible combinations, that would be a little ridiculous because this box is pretty massive. I'm only going to make you do what is in the actual squares. So what you're going to do is fill it in. You're going to write the genotype. I already know right here, right now, that I have 2 different kinds. So big H, big G, little g, and then I have big H, little g, little g, and then you're going to write out of 16 how many of those belong to each of those genotypes. And then for your phenotypes, you need to make sure that you try to condense it as much as possible and make sure that you include all of the possibilities. So if we take a look at this first one right here, that would be big H, so it's going to be tall, and it has a big G, so it's going to be green. So how you would write this would be tall and green. And then you would write your phenotype ratio for that. How you would do it for this one is, okay, so again, this one's going to be tall because it has 1 capital letter, but it has 2 lowercase g, so it's going to be white. And again, out of 16, how many of those do you have? Okay, so that is how you do the dihybrid cross.